Hello dear students, good evening. Today I am going to teach about what is scheduling, what is CPU scheduling, why we need CPU scheduling and what are the different types of CPU scheduling algorithms we will see in detail. Okay, don't miss to watch till the end. Okay, here see why we need scheduling. Right, a typical process involves both IO time and CPU time. I already told every process, if you are executing any process in your computer, it needs sometime it needs IO time. IO means what? Input output. Right, sometime it needs CPU time. Right, this point you have to keep in your mind. If any process is executing, it is taking IO time or it is taking CPU time. Actually, in uniprogramming system like MS-DOS, MS-DOS is a uniprogramming. What is the meaning of uniprogramming? Suppose if time spent waiting for IO is wasted. Here, suppose process P1 is currently executing by the CPU. This process P1 needs any IO input or output. That time, the process P1 is using IO time. That time CPU will become idle. CPU will become idle until the process P1 again comes and complete its task. Right? This is a CPU idle time. Time spent for IO is wasted and CPU is free during this time. Right? CPU is free. We are wasting the CPU time. But in multi-programming systems, what we are doing, one process can use CPU while other is waiting for IO. Here, what is a multi programming? In multi programming, what we are doing? If one process is waiting for some IO, I will give you one more picture for this. Here, first initially CPU is executing process P1. After some time, process P1 went for some IO. Now we can allocate CPU to process P2, which is waiting here, right? Process P2. Now, whenever process P2 is requesting for IO or if it is terminated, that time this another process, any P1 or if any other process can occupy the CPU. That means we are not keeping our CPU idle. CPU is always busy executing the processes here. This is called as multi-programming. I hope you understand the difference between uniprogramming and multiprogramming. In uniprogramming, CPU is idle when any process is going to execute IO. But in the multiprogramming, CPU is not idle. In the meantime, we are allocating CPU to other waiting process. Right? But here, what is the problem here? Here we need CPU scheduling. Right? Suppose I told only one process P2 is waiting here. Suppose here there are five processes P1, P2, P3, P4. Here four processes are waiting here. Now the operating system has to decide which process should be allocated the CPU. Here there is a scheduling is required, right? There is a scheduling is required. Which process should be allocated the CPU? That is called as CPU scheduling. This is possible only with CPU scheduling, right? And what are the different objectives of the CPU scheduling? Some more objectives are there. First one is maximum CPU utilization. We have to keep the CPU as busy as possible. We should not keep our CPU idle. First, fair allocation of CPU. We have to allocate CPU in a fair manner. Next one is maximum throughput. We have to achieve maximum number of processes should complete their execution per time unit. In any time unit, maximum number of processes should complete the execution with the CPU. Next, minimum turnaround time. We need to achieve minimum turnaround time. What is the meaning of turnaround time? The total time taken by a process to finish its execution. Once process is coming into this ready queue until its completion of its execution, this total time is called as a turnaround time. We have to minimize this turnaround time. Minimum waiting time, the time a process waits in ready queue. how much time a process is waiting in the ready queue to get the CPU. That is a waiting time, right? Minimum response time, time when a process produces first response, right? We have to minimize all these factors if you consider any process which is executing in the CPU. Now, what are the different types of CPU scheduling? First, you have to know types of CPU scheduling. First one is preemptive CPU scheduling. What is the meaning of preemptive scheduling? Preemptive scheduling is used when a process switches from running state to ready state. Right here, see, suppose here process P1, here it is in ready state. It is going to from ready state, it is going to running state, right? I have explained in the process state diagram. From ready state, once you are allocated the CPU, it is going to running state. Sometimes the process can come from running state to ready state. This is called as preemption. Preemption means a process come from running is coming from running state to ready state. What there are different situations a process can come from running state to ready state. See, when a process switches from running state to ready state or from waiting state to ready state. Why it is coming from running state to ready state? Because we are allocating CPU for a limited amount of time. Then it is taken away, right? And the process is again placed back in the ready queue. If that process still has CPU burst remaining, this process in a ready queue, right? I will tell you again, I will explain. See here, why it is coming, why we are removing CPU from this, suppose process P1, it is currently executing. We are removing process P1 and allocating CPU to process P2. Here process P1 again coming into ready state. Why? Because we are removing resource. We are removing CPU from P1 and allocating to P2. This is called as preemption. Some when there is a possibility of preemption, if it is a preemptive CPU scheduling algorithm, we will preempt the CPU from the current executing process and removing allocating CPU to some other process. Right? In time sharing systems, we can say that time sharing systems. Time sharing systems means we will allocate CPU to every process for a limited amount of time. Process P1, P2, P3, P4. Suppose P1 requires 10 milliseconds to complete its job. P2 requires 5 milliseconds. P3, P3 requires 3 milliseconds. P4 requires 2 milliseconds. But we are giving only for every process, we are giving 2 milliseconds of time initially. Right, ma? Here see, first process P1, we have allocated only 2 milliseconds. Immediately, we are removing and giving chance to P2. This is a preemption. Right? This is a preemptive type of scheduling. And next one is non-preemptive. What is non-preemptive? Non-preemptive scheduling is used when a process terminates or a process switches from running to waiting state. Here, once we have allocated CPU, we cannot remove. Here process ready state, process P1, it is going to running state. Here process P1 is having 100 milliseconds of CPU time. We cannot remove CPU from this process P1 until its completion. Once, if suppose when the CPU can free here, if suppose P1 requires any IO time in the middle of execution, process P1 requires some IO time. That time, this CPU can be allocated to the other waiting process. Here, suppose P2 is waiting. Immediately, CPU can be allocated to process P2. That means we are not preempting, we are not removing CPU from this process. Process P1 నుంచి CPU ని మనం రిమూవ్ చేయొద్దు. ఓన్లీ ప్రాసెస్ P1 ఒకవేళ ఇది కంప్లీట్ ఎగ్జిక్యూట్ అయ్యి టర్మినేషన్కి వెళ్తే, if it is going to termination state or if it is going to waiting state, then only In these two cases, only in these two cases, we can allocate CPU to other process. ఎప్పుడు ప్రాసెస్ P1 అనేది ఒకవేళ ఎగ్జిక్యూషన్ అయిపోతే దట్ ఈస్ టర్మినేషన్ ఆర్ ప్రాసెస్ P1 అనేది దీనికి ఎనీ ఐఓ టైం అవసరం అయితే అప్పుడు మాత్రమే మనం సిపియుని ఈ ప్రాసెస్ నుంచి రిమూవ్ చేస్తాం. అదర్వైజ్ వీ కెనాట్ రిమూవ్ సిపియు అండ్ we cannot give CPU to other process. This is called as non-preemptive. These are the two types. See, these are the two types of CPU scheduling. Non-preemptive means what, ma? In the scheduling, once the resources is allocated to a process, the process holds the CPU till it gets terminated or it reaches to a waiting state. Try to read this sentence one more time. If it is terminated or it is going to waiting state. In case of non-preemptive scheduling, does not interrupt a process running. Running lo unna process ni manam interrupt cheyalemu. We cannot interrupt this process. We cannot interrupt and we cannot allocate CPU to another process. That is interrupt, right? Until instead it waits till the process completes its CPU. P2, if P2 requires CPU, what the P2 should do? It should wait until the completion of P1. We cannot allocate CPU to P2. That is the meaning of non-preemption. There are different shortest job first. This is a shortest job first is two types. Non-preemptive type and preemptive SJF. Preemptive SJF is a non-preemptive SJF. In priority scheduling also, priority, non-preemptive priority and preemptive priority. See, I will tell you what are the different types of CPU scheduling algorithm. First one is first come first serve. Here process, suppose any process is coming into the ready, here P1, P2, P3, P4 are came into the ready queue. Which ఏ ప్రాసెస్కి మనం సిపియూ అలొకేట్ చేయాలి? ఇక్కడ ఏ ప్రాసెస్ ఫస్ట్ వస్తే దానికి సిపియూ. సపోజ్ P1 కేమ్ ఫస్ట్, we have to allocate CPU first to process P1. After P1, P2 came. P1 after P1, which process will get the CPU? P2. After P2, which will get the CPU? P3. Like that, first come first serve. Here, simplest scheduling algorithm that schedules according to arrival times. First come first serve scheduling algorithm states that the process that requests the CPU first is allocate the CPU first. Whichever the process is requested first will get the CPU first. That is about first come first serve CPU scheduling algorithm. It is implemented with the help of FIFO queue. When a process enters the ready queue, its process control block is linked to the tail of the queue. Right? FCFS is a non-preemptive. Just now I told, right? There is a preemptive and non-preemptive. FCFS is which type of CPU scheduling algorithm? It is a non-preemptive because once we allocated CPU, we are not removing CPU from the process. Right? Next one is shortest job. What is the meaning of shortest job? ఏ జాబ్ అయితే తొందరగా కంప్లీట్ అవుతుందో దాన్ని షార్టెస్ట్ జాబ్ అంటాం. సపోజ్ P1 needs 3 milliseconds, P2 needs 100 milliseconds. Which is shortest job here? P1 is shortest job because it is taking less time to complete its execution, right? That is shortest job first. Here this shortest job first is two types. One is preemptive, next one is non-preemptive. Preemptive SJF, non-preemptive SJF. Right? Try to understand. In FCFS, it is only preemptive, non-preemptive SJF. Non-preemptive FCFS. Right? Next one is longest job first. Sometimes P1, suppose P1 is 100 milliseconds, P2 is having 3 milliseconds. The CPU will be allocated to process which is having longest CPU time. Next, shortest remaining time first. It is called as preemptive SJF. Preemptive SJF ni manamu, what is other name for the preemptive SJF? Shortest remaining time first. Next, longest remaining time first is preemptive LJF, preemptive LJF. Okay, now next one is round robin scheduling. What is the meaning of round robin scheduling? Here we are allocating for every process we are giving some time quantum. That means 2 milli. Suppose I am giving 2 milliseconds to each process. P1 requires 2 milliseconds, P2 requires 4 milliseconds, P3 requires 5 milliseconds. Suppose, right? First P1 it will get 2 milliseconds. Next after that P2 it is also getting 2 milliseconds of CPU. Next after that P3 it is also getting 2 milliseconds. Again P1 will get chance, right? P1 already completed, right? Because it is required only 2 milliseconds. Next P2. P2 requires more 2 milliseconds. Now it is again after P2 it will go to P3. Like this, it in a circular manner, every process is getting the CPU. What is a priority based scheduling? In priority scheduling, we are allocating the CPU based on some priority. We are for every process we are allocating some priority. Suppose P1, P2, P3. P1 is having priority 1, P2 is having priority 2, P3 is having priority 3. Here lowest number is highest priority. That means P1 is highest priority. Suppose in the question if they gave highest number is highest priority means P3 will get highest priority. Based on the question we have to decide which is having highest or lowest priority. Generally smallest numbers they will give smallest numbers as the highest. P1 has highest, next P2, next P3, like this. Now see, before going to solve CPU scheduling questions, you have to know all these terminologies. First one is arrival time. Time at which process arrives in the ready queue. Process ready queue loki eppudu ochindi? Suppose P1 came at 0 milliseconds. This is arrival time. P1 came at 0, P2 came at 1 milliseconds, P3 came at 2 milliseconds. This is arrival time. Next one is completion time. When process P1 is completed, it is came at time 0. Suppose it is completed at 10 milliseconds time in the CPU. In the CPU, if it is completed at 10 milliseconds, this is called as completion time. Burst time. What is burst time? Time required by a process. Burst time అంటే ఏంటి? దానికి టోటల్ ఎంత టైం కావాలి? సపోజ్ ప్రాసెస్ P1 కి దాన్ని ఎగ్జిక్యూట్ చేయడానికి ఇట్ నీడ్స్ 100 milliseconds time అనుకోండి. It needs total 100 milliseconds time. That is called as burst time. Total time required to complete. Turnaround time formula ఏంటి? Completion time minus arrival time. Waiting time. What is the formula for waiting time? Turnaround time minus burst time. Right? Now, I will give you examples. The two examples I will give you. Please wait. Okay, first process burst time 574, arrival time 013, P1, P2, P3. We have to calculate the average waiting time and average turnaround time with the help of round robin CPU scheduling algorithm. Here time quantum is given as 2 milliseconds. Right? To solve these type of problems, what we have to do? We have to draw a Gantt chart. Always remember the CPU execution will start from 0 milliseconds. Ikkada 0 milliseconds, which process came into the ready queue at the time of 0? Process P1 came. Right? That's why we are allocating CPU to process P1. And we have to allocate to only 2 milliseconds because it is time quantum. మనం CPU రౌండ్ రాబిన్ షెడ్యూలింగ్లో మనం ఇంకొక క్యూ మెయింటైన్ చేయాలి ఇక్కడ. ఎందుకంటే నెక్స్ట్ మళ్ళీ ఇవే రిపీట్ అవుతాయి కదా. ప్రాసెస్ P1కి ఎంత టైం అలొకేట్ చేసాం 2, ఇంకా రిమైనింగ్ టైం ఎంత ఉంది ప్రాసెస్ P1కి 3 మిల్లీ సెకండ్స్. కానీ బట్ వి విల్ ఓన్లీ 2 మిల్లీ సెకండ్స్ అలొకేట్ చేసాం. నెక్స్ట్ ఆఫ్టర్ P1 who will execute P2. P2కి ఎంత టైం ఇస్తాము, దిస్ ఆల్సో విల్ గెట్ 2 మిల్లీ సెకండ్స్. ఇంకా రిమైనింగ్ టైం ఎంత P2కి 5, రైట్. 2 + 2 ఇక్కడ we have to add 2 this 2 + 2 4. నెక్స్ట్ ప్రాసెస్ ఎవరు which is waiting in the next P3. Here we have to check this arrival times also. At the time of 4 P3 came, right. P3 kuda how much time it will get 2 milliseconds. 4 + 2 6. ఇంకా రిమైనింగ్ టైం ఎంత ఉంది P2కి, P3కి 2 ఉంది. నెక్స్ట్ P1 P2 P3 in this order again. P1 will come, right. P1 will execute here. P1, what is the remaining burst time of P1? 3 milliseconds, right. But we will give only 2 milliseconds. Remaining time ఎంత ఉంటుంది, ఇంకా 1 millisecond. 6 + 2 8. నెక్స్ట్ ప్రాసెస్ P2కి రిమైనింగ్ బర్స్ట్ టైం ఎంత 5. కానీ మనం ఎంత టైం అలొకేట్ చేస్తాము, ఓన్లీ 2 milliseconds. 5 - 2 అంటే 5 - 2 how much, 5 - 2 3. 8 + 2 10. ఇంకా ఇక్కడ 3 milliseconds రిమైనింగ్ ఉంటుంది. ఇంకా P3కి రిమైనింగ్ ఎంత ఉంది, P3 రిమైనింగ్ 2 కదా. P3 remaining 2. We will allocate these 2 milliseconds. 10 + 2 12. P3 complete అయిపోయింది. నెక్స్ట్ ఎవరు, నెక్స్ట్ P1. P1 remaining time ఎంత, what is the remaining time of P1? P1 remaining time is 1. That means 12 to 13 P1. Next who is remaining, P2. Here P1 is completed. Next who is waiting, P2. What is the remaining time, 3 milliseconds. మనం ఇక్కడ 2 allocate చేయాల్సిన అవసరం లేదు, ఎందుకంటే here P1 is completed, P3 is completed. No one is waiting. కాబట్టి P3 will get complete time. 13 + 3 16. మనం ఇక్కడ turn around first we have to take completion time. What is the completion time from this Gantt chart? మనకి Gantt chart లో ప్రాసెస్ ఎక్కడ కంప్లీట్ అయిపోతుందో దాన్ని కంప్లీషన్ టైం అంటాం. ప్రాసెస్ P1 అనేది ఇక్కడ కంప్లీషన్ అయిపోయింది. దట్ మీన్స్ దిస్ ఈస్ కంప్లీషన్ టైమ్ ఆఫ్ ప్రాసెస్ P1. P2 ఎక్కడ కంప్లీట్ అయింది, ఇక్కడ 16. P3 కంప్లీషన్ ఇక్కడ P12. వాట్ ఈస్ ద టర్న్ అరౌండ్ టైం ఫార్ములా, కంప్లీషన్ టైం మైనస్ అరైవల్ టైం. కంప్లీషన్ టైం ఎంత, ఇక్కడ 13. 13 - 0 13. What is the completion time, turnaround time for P2? 16 - 1 15. That means completion time minus arrival time. What is the turnaround time P3? 12 - 3 9. Next waiting time. What is the formula for waiting time? Turnaround time minus burst time. అంటే ఏ ప్రాసెస్ కి దాంట్లో నుంచి రిమూవ్ చేయాలి మనం. What is the turnaround time of P1? 13 minus how much, burst time of turnaround time minus burst time. Yes, 13 minus 5 how much, 8. Waiting time of P1 is 8. Next, what is the waiting time of P2? 15 minus 7 8. What is the waiting time of P3? 9 minus 4 5. Average waiting time ఎలా find out చేయాలి, 8 + 5 by 3. This is average waiting time. I hope you understand, right? 12. This is average waiting time. Average turnaround time how much? 13 + 15 + 9 divided by 3. This is average turnaround time. This is how you have to do in the round robin scheduling. Try to listen one more time and you will get to know what is this. Right, next I will explain one more question. Here there are processes P1, P2, P3, P4, P5 and burst time 27. P1 burst time is 27, 12, 37, 12, 37, 19, 10 and arrival times are 0 1 2 3 4, 0 1 2 3 4. right? First you have to do with FCFS and SJF. Find average waiting time and average turnaround time with FCFS and SJF. I will just explain the Gantt chart. The remaining things you have to calculate. Okay. FCFS. What is FCFS? First come, first serve. See which process came in first into the ready queue. Arrival time. You have to check the arrival time. First, before all P1 came first, right? CPU execution start at 0 in the CPU. Process P1. What is the burst time of process P1? 27. It is a non-preemptive. That means it will complete its execution. Next, after that, after P1, P2 came. 27 plus 12. How much? 39. Next, after P2, P3 came. That is 39 plus 37. How much? 76, right? Next, after P3, P4 came. 76 plus 19, 95, up to 95. After P4, P5 came. 95 plus 10, 105. With this Gantt chart, you have to find the completion time, turnaround time, and waiting time. First, write the completion time of P1, 27, P2, 39, P3, 76, P4, 95, P5, 105, and find turnaround time. Completion time minus arrival time. Like this, you have to complete this and send me the answer. Next one is SJF. How to do the SJF? SJF is here initially CPU started at 0 milliseconds time. SJF means what? Whichever is having shortest burst time, it will execute first. But here arrival time is also given. We have to check the arrival time also. In actually P5 is having least burst time, right? P5 is having least burst time, but it is not came initially, right? That's why we have to allocate the CPU for P1. P1 will execute up to 27 milliseconds. Now by the 27, by the time in the CPU time is 27, by the time 27 all the processes are waiting, right? P2 came at 1, P3 came at 2, P4 came at 3, P5 came at 4. That means now we have to check which is having least burst time out of the waiting processes. ఈ వెయిటింగ్ ప్రాసెసెస్ అన్నిటిలోకెల్లా తక్కువ బర్స్ట్ టైం దేనికి ఉంది? P5, right? P5. 27 plus 10, 37 because P5 burst time. Next which is having least? P2. P2 how much? 12. That means 39. Next burst time, least burst time is P4. P4 is 19. 49, 58, right? Next P3. Like this, you have to complete this Gantt chart, right? 27 plus P5, 37, P4 is 19. 37 plus 19, how much? 16, 56. Here 56. Here, sorry, wait 1 minute. Addition, we have done mistake in addition. P4 is 19. 37 plus 19, 56. P4 burst time is here, not P4. After P4, which will be executed? 27, P5, P4. Next, here P2, not P4. Here P2. 37, 27, 37 plus 12. Here plus 12. We have to do plus 12 here. Okay, 37 plus 12, how much? 37 plus 12. 49. 49 plus P4. P4 waiting time is 19. 49 plus 19. 68. 68 plus the next last one is 68 plus 37. 105. With this Gantt chart, you have to find all these things. Okay. Thank you everyone. I hope you understand. Please complete this problem and send me the solution.